Hey, my name is Miriam Mayadi. I'm a senior data scientist at Alteryx. Now, I think that a lot of you know that Alteryx is a powerful data analytics platform, but also one that's particularly intuitive. And I've seen that firsthand so many times. There is nothing like meeting a customer that thanks you that your product exists. And I'm talking about all sorts of people with varying levels of expertise, with all sorts of systems and decisions to make. And here is just a glimpse of that. 8,400 customers from finance to retail to tech. And we go from data analytics and preparation to machine learning, geospatial, automatic insights, with deployments on-prem and in the cloud, as well as hybrid. One thing I want to start us with here is how often we're being asked to increase efficiency in projects, right? Totally understandable. Now imagine if those projects have direct impact on the day-to-day lives of people. I want to tell you about an analyst that works at the US Department of the Interior, the kind of stuff that comes their way, unbelievable. Long-lasting damages to families, businesses after flooding. And our analyst needs to identify the areas as well as the populations that are most impacted by flooding in the next 10 years. Of course, another important thing is having mitigation strategies that could be implemented. Now, mind you, this analyst is not a data scientist. She's the person we all have in our teams that just knows the product really well and knows the domain in particular the best. So she is the one being tasked to figure out a solution over here. She starts out by going to Alteryx Designer that we're seeing over here in order to prepare her data for further analysis with just a few drag and drop clicks. So on the left-hand side, we see that she looks at her input data, the OECD, and of course, she gets the classic data cleaning nightmare. Lots of information squeezed into one cell. So she does a little bit of cleanup to get it in a much better state. Now, the other thing the analyst knows is that in order to prepare her data for machine learning analysis further down the line, she needs to, for example, pivot a few rows into columns so that it fits that sort of format that she needs for machine learning. Now, of course, there is yet another issue with the OECD data set. The way sort of it matches and defines regions and the granularity that it uses is a little bit all over the place. So our analyst over here uses the join tool in purple in order to further enrich and clean up her region columns. Now, to further enrich, on the other hand, her analysis, the analyst is also looking to use additional data sets, in this case, the flood insurance data from FEMA, and she wants to sort of double check if her hunch on whether flood insurance data is even an angle worth exploring. She opens up Alteryx Auto Insights. So here, this is in the cloud. The analysis is automatically created for her. She just needed to input some data, and there's no intervention like sort of traditional BI that we might be used to. Now, if we look a little bit closer, we could see that the total number of payouts that were made almost doubled in the past decade, so 20,000 to 40,000, which basically tells us that really the risk of flooding is increasing and it's something we should pay attention to. Now, further down, we see that by far Louisiana and New Jersey are the biggest contributors to that increase. And that gets the analyst interested in potentially looking at additional states like the state of Montana, where she's seeing some interesting results. Here, the analysis show her quite significant peaks in the year of 2011. This is the number of claims that were filed, as well as in 2018. So that gets the analyst thinking I should probably reach out to, for example, the director of emergency response in the state of Montana to get a little bit more detail on this. And to help her out speed things up, she leverages the generative AI capabilities within Auto Insights in order to create an email that summarizes and creates that template for her to send out, showing all her findings so far. Now, the analyst is also interested in further enriching her data set with demographic information. We know that that would be extremely telling for the analysis to get a little bit of an understanding of who might be impacted. And here, cherry on top of the cake, one of Alteryx's secret weapons, the data pack. Here, the analyst uses that to understand the who, and the kinds of things that you get is granularity from zip level to state level. You get information about household, age, other demographic information, all in one place, nicely integrated, no need for lengthy coordination with IT. Alrighty, let's jump back into Designer. Now, with both the FEMA insurance data and the built into Alteryx demographic information, the analyst was able to look at past effects of river flooding. Now that she has her data nicely prepared, she is interested in looking at the future. So in this case, where are the geographical areas with the highest risk of flooding, as well as who is the most likely to be impacted? So her next step is to create a model for that. Now, luckily, in her previous team, there was a data scientist that worked on exactly that. And that person loved coding in Python. Luckily, all of that modeling work is all within Alteryx Designer, and so our analyst is able to easily reuse that. Now here, we have a macro, which is basically a way for the analyst to reuse the Python code without having to need basically to touch the code herself. Now here, we also get a sense of behind the scene, what was that data scientist looking at in her prediction analysis? We see that she created sort of a merge of different pieces that came from the OECD input data. So we're seeing urban areas, population, cropland being turned into one measure. Now, our analyst wants to make sure, since it's been a while, that the work that the data scientist has done, the Python fan, is still valid. For that, she decides to swap the Python with something she is more comfortable with. And those would be the Alteryx predictive tools that we see up here in brown. These basically give you sort of a series of pre-built models that you get to pick from accordingly. Now, remember, the analyst is trying to create this sort of composite unified score that takes all of the variety of measures from the input data, OECD, but creates really one output, one number. Over the years, is the risk of flooding in a particular region going up? Is it decreasing? Is it not changing much? So dragging a simple regression tool really does that for her. Because the gist of what we're trying to do here is really just fit a line over time in order for us to understand our trend. So now our analyst has her scoring model, and then she supplements it with geospatial capabilities within Alteryx Designer. So over here, she is able to start answering the question where, identifying basically the geographical areas with the highest risks of flooding. And if we look closely, these flags in Montana and Wyoming, for instance, are fairly aligned with the Rocky Mountains, which first of all confirms that Montana is indeed a state that is at high risk, likely due to snow melting in the mountains. Now, the analyst just answered the where question. She is interested next in who. And for that, she leverages Alteryx machine learning to help her with further exploration. So to get an answer to her question, she needs some further experimentation with a diversity of models. And in Alteryx machine learning, automated modelings will be run on her behalf to get her there. So with that, we jump to the cloud and in the browser. Here we see, for example, that everything is brought together. So the demographic information from Alteryx's secret weapons, the data packs, as well as the model that she just created in order to score the trends over time. Next, she's able to look at, for example, correlations between her columns, maybe information about her target. And here she's able to, even by a click of a button, further enrich her model with interesting columns. That's what we call feature engineering. And she's able to get further guidance on that using our education mode. And lastly, of course, she gets to pick a model that was automatically created for her as a best fit for her experiment. Now we get to a bit of a plot twist. When looking at the feature importance, so column importance, we see that it suggests that regions with a high Native American populations are associated with high risks of flooding. More on that in the next section. In our last section, the analyst had created her model with predictions about where river flooding is most likely to occur in the next 10 years. We also saw an answer to who, which populations were most at risk of impact. Now our analyst is ready to share her findings. I'm sure that many of you can relate to the fact that so many models don't quite make it into production. But here we have an analyst that genuinely cares about making sure that her model can be used to truly solve this real world problem and not just end with her, which is something that we see happens a lot. People make this stuff a little bit complicated and it shouldn't be. So our lovely analyst goes back into Alteryx machine learning here in the cloud. She has the option to export her model, then for deployment into Designer. Jumping in here, I want to first pause for a moment. Frankly, what do we all know we really need after the creation of a model? Two simple things. We want to be sure that we're able to schedule and automate the model. That way, when new data comes in, everything is refreshed properly, right? The other really important thing is that we want to make sure to get a proper notification when, for example, something goes considerably off the tracks or even when it does just a little bit. And these are things that we at Alteryx believes are actions that an analyst should and can be able to handle. Simple. So, our analyst starts by looking at our input data over here. She creates a workflow that basically tells her if there are too many missing values maybe, or if the data seems to have shifted significantly compared to what she knows. And this is what the industry likes calling data drift. In other words, has my data still have basically similar characteristics to when I first created the model? Now, speaking of the model, the other piece she looks at here at the bottom right is the output of it. So how is it performing after we've had a refresh of the data? And here she creates a workflow as well to monitor just that and basically keep an eye on what we call model drift. Now, the analyst also knows that her stakeholders, like that Montana state liaison, really needs a model that they understand and they feel comfortable basically using. So for that, we are going to talk a little more about model explainability in Alteryx machine learning. So going back to what we had initially, we'll see that we got the answer to the who, the population that was most associated with high risks of flooding. But in the next screen, if we look at partial dependence, for example, we can get even more details. So here, for instance, what specific values do we see making the change over our values? And if the analyst is interested in digging even deeper into model explainability, she's able to jump into this simulation screen that lets you pick values all the way at the row level of her data. Now back to the idea of sharing and actioning on these models. Our analyst is able to save her model into what we call Alteryx server. When going to the browser, we get a nice interface. Here, Alteryx server basically acts as a centralized repository for workflows and models that people can then share, collaborate all across the organization. Now, earlier, we mentioned that we expect our data to come in on a monthly basis. So this is where the analyst is able to schedule accordingly the cadence that she is interested in. Of course, if we navigate to a folder that has a specific workflow she's interested in sharing with colleagues, she is able to do that and gain control on who and what people can see from the model that she shared on server. Alrighty, we made it. We're now finally able to meet with our stakeholders. But we all know that, of course, governments and private institutions have a lot of constraints around resources and time, so they need us to prioritize the high-risk areas for them to deploy their resources accordingly. So here, using App Builder in the cloud, available in a few months, the analyst creates a drag-and-drop web application that her stakeholders, like the Montana State Liaison, can easily use and customize. Of course, all of it with no lines of code. So let's have a closer look. We see that it summarizes all the findings we have so far, the high-risk areas we flagged, the populations that are most at risk. For instance, a high one that we're seeing here is bighorn, which we highly encourage the state of Montana to pay particular attention to. Now, with the constant innovation that we see here at Alteryx, we're able to leverage technologies like ChatGPT straight into our products. Remember the predictive sort of unified model that our analysts had created before? That one, of course, told us about the areas that are getting worse over time in terms of river flooding. But the flip side is certain regions and certain countries have actually been doing better and are making progress in this space. One of them in particular is the country Colombia. So we go ahead and ask GPT specifically a question around Colombia that focuses on the best practices that have already worked for them. And the result that we get gives us a little bit of insights for us to create our own mitigation strategies. So here we pick up on construction of flood control infrastructures, flood forecasting and warning systems, as well as public education and awareness. Now, of course, our analyst was already in touch with the Montana State Liaison. That person gives her a little bit more context to curate the mitigation strategies for Montana in particular. And for that, we add things like supporting tribal organizations and implementing traditional ecological knowledge. Now, let's move to what we have all been waiting for, and that is showing our suggested mitigation strategies directly on a real map. So let me start us out with the Yellowstone River over here in Montana. What we're looking at is the location intelligence in Alteryx in the cloud. This is going to be available in a few months. It was used by the analyst to pinpoint specific areas to implement the recommendation strategies like sandbags and levees. Those will need to be placed in high-risk areas, in particular near the bridges, as those would be the most critical infrastructure pieces that get affected during flooding. Now, another piece we could look at is structures. These are buildings that we're seeing in yellow over here. That would be where people are actually living. Now, to get a sense of how far of a range one should go in, and we see that flowing along the river, we add a layer in blue that shows us the areas that are most prone to be impacted. Now, lastly, we could also add a layer representing the agricultural areas that should also be accounted for. And with that, I want to end with an interesting story, which is that Alteryx has worked with FEMA in the past in such problem resolutions, and we look forward to collaborating with many more of you in the future. Thank you.